Hi, welcome back to Moose and Chemistry. We're going to do the VSEPR model lesson number 5 for the compound BI3. Okay, let's look at some things about B. B is in group 13, so it's going to have 3 valence electrons. 1, 2, 3. I is in group 17, so it's going to have 7 valence electrons. There we go. Alright, so let's see what happens with the structure. Let's do some math here. So boron has 1 times 3 electrons. Iodine has 3 times 7 electrons. This is going to give me 21 electrons here. This is going to give me 3 electrons there. And that's going to give me a total of 24 electrons. So whatever structure I put together is going to have 24 electrons, right? So let's go ahead and draw the structure to see if this is going to work. So I'm going to put the structure right here in the middle. And I'm going to put an I here, an I here, and an I here. So I'm going to connect this I to this B, this I here, this I here. So now we're going to put in our 8 electrons around our I's, because they're wraparounds, right? So 1, 2, 3, 4, 5, 6, and that dash equals 2, that's 8. So 2, 4, 6, 8. 2, 4, 6, and 8. All right. So now, is this the best possible charge? We're going to use something called formal charge. So, formal charge of boron. So we take the valence electrons minus the bonding electrons minus the non-bonding electrons. Okay. So now, let's see what we've got here. Boron came in with 3 valence electrons. Bonding electrons, we have 3 bonding pairs. And we have 0 non-bonding electrons. So that gives me 0. And that's a very good sign that we did it right. Let's do the formal charge for one of the iodines. That's important. And let's see, iodine came in with 7 valence electrons. Bonding electrons, minus 1. Non-bonding electrons, there's 6 of them. So that gives me 0 also. So this proves that this is the best possible structure. Now, let's look at something else about this structure. A, X1, X2, and X3. You could put those in any order. And so this would be AX3. That tells me when we look on this chart up here, we find AX3. Let's go ahead and find that. It's right here. Okay, this means that this structure is trigonal planar. Its hybridization is sp2. And the bond angles are 120 degrees. Okay, so what that means is that, like, for example, from here to here is 120 degrees. Here to here is 120 degrees. And of course, from here to here is 120 degrees. Well, that's it for this lesson. You guys be snarly, and we'll see you back here at Moose and Chemistry.